Okay, so this is question 14.109. Now, sometimes these are a little bit tricky because this is stuff you could go look up, but on an exam, I would give it to you. So it's a little bit hard with the practice exams because I do have to, I'm limited by what questions I can pick. And so I do pick ones that, maybe you don't have as much information as you would have on the exam. So I would give you the KF and the KB of water. And I would also assume an I of 1. Now, the KF and the KB, you could have looked those up. The I in this instance isn't actually part of the problem. You can kind of just negate it. Now, normally, I is equal to 1 for a covalent compound. And I is equal to the number of ions for an ionic compound. Okay, so you can go back and review that if you need to. Now, like I said, in this one, we can kind of ignore that. So what we're going to do is use the equations. Delta T, the change in temperature for boiling, is equal to ImKB. Again, we're going to ignore I or make it 1. And the delta T for freezing is ImKF. Well, we don't actually know the molarity of this, the molality of this solution, but we know the delta T, right? It started at 100 and it went up to 106.5. So the delta T here is equal to 6.5 degrees C. And we know that the KF is 1.86. So we can actually solve for the molality and then plug it back in to this equation. Okay, so we're using the boiling point equation to find the molality, and then we're going to use that molality, because it's the same solution, we're going to use that molality in the freezing point equation. So I'm going to take 6.5 divided by 1.86, and I get that the molality is equal to 3.49. And this is moles per kilogram solvent, just in case you forgot what molality is. And now I'm going to plug that back into this equation. Delta TF equals 3.49 times the KF, which is 1.86. Oh, I just realized I did that wrong. I'm sorry, guys. Let me back up a little bit. I used the KF, not the KB up here. So redoing that calculation, 6.5 divided by 0.512. Ooh, that's a really high molality. So that is actually equal to 12.695. Okay, so now, sorry for the TF, we're going to do that molality times KF, which is 1.86, and that'll give us the delta T. Now remember this number, that's the change. So the new freezing point, which I think that's what the question asks about. Yep, what is the freezing point is going to be negative of that because the original freezing point was 0. So 12.695 times 1.86 means that the new freezing point is negative. So this number is positive, 23.6, which means that the new freezing point, and it says 2 sig figs, so I'm going to go ahead and give that as negative 24 degrees Celsius. Okay, so you're using both of those equations in order to do the problem.